back to the fifth lesson on reversible reactions, where we are going to discuss Le Chatelier's principle and the changes in pressure on a system in equilibrium. Now, pressure will only affect gases. If there is an increase in pressure on a system containing gases, the reaction that will produce less gas will be favored, as less gas will exert less pressure. The opposite is true. When the pressure is decreased on a system containing gases, the reaction that will produce more gas will be favored, as more gas will exert greater pressure. So we're going to look at the examples under the heading pressure, changing the pressure, on page 176. The first one, you have 2 moles of nitrogen monoxide reacting with 1 mole of oxygen to give 2 moles of nitrogen dioxide. Now, to consider the fact of pressure change, we need to see that on the reagent side here we have a total of 3 mole of gas, and on the product side on the right we have a total of 2 mole of gas. So on the left hand side of the arrows you have more moles of gas than on the right hand side. So let's look at the effect of an increase in pressure. Now, according to Le Chatelier's principle, the reaction that produces less gas is favored. So that implies that the forward reaction is favored. And to say it in other words, the equilibrium shifts to the right. So your concentration of nitrogen dioxide will increase, while the concentration of nitrogen monoxide will decrease, and the concentration of oxygen will decrease. To look at the second one, we see that we have 1 mole of hydrogen for every 1 mole of iodine, and there will be 2 moles of hydrogen iodide forming. So here you have 2 moles of reactants compared to 2 moles of products. So a change in pressure will not have any effect on this equilibrium. Right, to go back to number A, the opposite will be true if you decrease the pressure. The reaction that will produce more gas will be favored, so that would be the reverse reaction. So your concentration of nitrogen monoxide as well as oxygen will increase and the concentration of nitrogen dioxide will decrease. Next we go to page 178 and we're going to do number 1.5 where we have our favorite nitrogen dioxide in equilibrium with dinitrogen tetraoxide. So to see the ratio, mole ratio, 2 moles of the nitrogen dioxide is in equilibrium with 1 mole of the dinitrogen tetraoxide. So in the diagram shows a sample of nitrogen dioxide in a gas syringe. Use Le Chatelier's principle to decide what will happen when the plunger of the syringe is pushed in or pulled out. Label diagram 1 and 2 to show which syringe contains more nitrogen dioxide and which contains more dinitrogen tetraoxide. So pushing plunger in. Does two things. One, it decreases the volume. And because concentration is mole over volume, if the volume is decreased, the concentration of gas is going to increase. If the concentration of gas is going to increase and you've got a brown gas and a colorless gas, and you push the plunger in, the gas mixture turns darker. But it happens only for a few moments. The reason for that is point number 2. You're increasing the pressure on the system. And according to Le Chatelier's principle, that would favor the forward reaction. Therefore, more of the colorless dinitrogen tetraoxide gas is formed. So after the gas turned darker for a few moments, the overall change in color will be from darker brown to a lighter brown. The reason is the concentration of dinitrogen tetraoxide is increased and the concentration of nitrogen dioxide will be decreased. So the equilibrium shifts to the right. Right, now space is a problem, so I'm going to verbally describe the plunger being pulled out. So if the plunger is pulled out, there will be an increase in volume, so the gas mixture will turn lighter for a few moments. Pulling the plunger out also decreases the pressure. So according to Le Chatelier's principle, that would favor the reverse reaction to produce a darker color nitrogen dioxide. So the overall change in the color will go from the original brown color to a darker brown color because the reaction shifts to the left, producing more nitrogen dioxide and less dinitrogen tetraoxide. Lastly, we will look at the Haber-Bosch process, and here we can see that 3 mole of hydrogen reacts with 1 mole of nitrogen. So on the left hand side of the arrows you've got 4 moles of gas compared to the 2 mole of gas on the right hand side. So for the sake of completeness, I'm first going to say what happens when the pressure is decreased. According to Le Chatelier's principle, a decrease in pressure will favor the reaction that produces more gas. Now, if we look at the reaction equation, that is the reverse reaction will be favored. So the equilibrium will shift to the left. Your concentration of hydrogen will increase, your concentration of nitrogen will increase, and your concentration of ammonia will decrease. So, if pressure is increased, what will happen to the rate graph? I'm going to look at this part of the graph only. The moment that the pressure is increased, both the rate of the forward reaction and the rate of the reverse reaction will be increased, but the forward reaction is favored. It will increase more, and the new equilibrium will be reached at a higher rate. How will the concentration graphs change if the pressure is increased? Here you can see that if pressure is increased, there is an increase in all the reagents concentrations, but the reaction that is favored is the forward reaction because it produces less pressure with less gas present, and the concentration of hydrogen will decrease and concentration of nitrogen will decrease because the forward reaction is favored. When we look at the rate graph when pressure is decreased, we can see that the rate of the forward reaction is decreased more. So the reverse reaction is favored. This reverse reaction is favored. That's why it drops less when there is a decrease in pressure. Looking at the concentration graphs, if you decrease pressure, then you favor the reverse reaction, so the concentration of the hydrogen will increase as the reverse reaction is favored, the concentration of the nitrogen will increase and the concentration of the ammonia will decrease. Decreasing pressure will decrease all the concentrations by the same amount before equilibrium is re-established.